In this video, I'm presenting you a benchmark for Artificial General Intelligence or AGI. AGI simply means Human Level Intelligence acquired by Artificial Intelligence Systems or LLMs or VLMs. This new project, which is called as ARC-AGI, is simply a psychometric test for both humans and for artificial intelligence applications to test their AGI level. In simple words, ARC can be seen as a AGI benchmark, as a program synthesis benchmark, or as a psychometric intelligence test. It is targeted at both humans and AI systems that aim at emulating a human like form of general fluid intelligence. So, what happens in this is that this repository contains ArcAGI task data as well as a browser-based interface for humans to try their hand at solving the task manually, and we will also check it out. Whenever a task or test is being attempted, then the test taker, whether it's a human or an AI system, they are set to solve a task when upon seeing the task for the first time, they're able to produce the correct output grid for all test input in the task. That includes picking the dimension of output grid and all that stuff, and I will also show you shortly. Before I do that, let me give a huge shout out to Mast Compute who have sponsored this VM and also the GPU card which I will be using for this. You really don't need a GPU or anything like that for this video, but as I'm using their VM, so it's all so credit goes to them for this generosity. If you're looking for an affordable GPU, then I will drop the link to their website plus a coupon code which will give you 50% discount on an already discounted offering. So do check them out if you like. Okay, so the first step which we need to do is to git clone this repo. So let's go up, click on this code green button, grab the URL repo, go to your terminal. This is the terminal I'm using, and you see this is NVIDIA card, NVIDIA RTX 6000 with 48 GB of VRAM which I'm using. And now then to git clone, paste the URL of that repo which we have grabbed, and that is done. Let's go to in that Arc repo. Let's clear the screen and see what exactly inside it. So mainly you will be dealing with either apps or data columns or directories. This data directory contains some tasks for training and evaluation, around 400 of them, and apps contain the application which opens in browser to actually take the test. So let's try it out. So I'm just going to go into this directory in my file explorer and then go to ArcAGI where you have just cloned it, and go into apps directory, and there you will find this HTML file testing underscore interface.html. Double click on it and it is going to open it in your browser. You can go with the random task or you can click on browse. When you click on browse, you can go to again your home, your ArcAGI, your data, and then go to training, and from here you can select any task you like. So maybe I'll just go with any one of this JSON file, and this is our test space where you can take the test. Now if you look at this one, what is happening here is that this is a test space. On the left we have this input output pair demonstrating the nature of the task. In the middle there is a current test input grid, and then on the right you will see the control. You can use a construct used to construct the corresponding output grid. And then for the tools, you have two tools available. As you can see on the right, you have grid control where you can resize or you could copy from the input, and then you have symbol control where you can select a color, and then you can click on a cell to set its color, or you can even select by clicking and dragging on either the output grid or the input grid to select it. So you can just randomly select it or start implementing this, and you can select the random task by clicking on at the top like this random, and then you can just go with whatever you like. So for instance, I will just go back to the browse and maybe I'll just select any other task. There you go, this is a 1.21, and then you can also resize the grid from here if you like, and then you can click on copy from input and it is going to populate your this side. You can, for example, you just want to mimic this one, So from here, let's say you want to create this L on the right hand side here. So for that, maybe you can just click here and select this color, and then maybe we will just also make it maroon. And then for L, I'm just going to click here, click on black, and then here, and then maybe I'm just going to make it all maroon. This is all maroon, so looks like this. And then again, we have this blue line in the center, which is fine. And I'm also going to make it maroon here. And I'm just going with the top left diagram at the moment, just for the fun of it. Let's select black and make it here and here and then here. And we don't need these two, so I'm just going to make them maroon. And then make these blacks. And then it looks like that, right? Okay, and then we have to, can I submit it? I'm not sure. Okay, wrong solution. Okay, so maybe what I'm missing here, I'm not sure. Anyway, I'm not going to waste your time, but seems like fun, right? So now, so this is what we humans are doing, their cognitive skills. So you can similarly, if there is a vision model, we can also give that to that vision model and see what that vision model does. And similarly, we can also try to use competition between both vision models and our human intelligence to see how this thing works. Now, another thing which is quite interesting is that some people are also doing some Kaggle competition on it. So if you're interested, you can go to their GitHub repo and take part in that competition. There is also some sort of, I checked out that some cellular automata tools which are also people are trying to build to solve it automatically. So it should be interesting what can be done with it. So I think that to make the deliberate progress towards more intelligent and more human-like AI systems, we need to be following an appropriate feedback signal. We need to be able to define and evaluate intelligence in a way that enables comparisons between two systems as well as comparisons with human. But this is where I think this project seems quite interesting, as they have summarized and sort of critically assesses these definitions and evaluation approaches. They also have a paper related to this, so which is available in their GitHub repo. I would highly suggest reading it if you are interested. Quite interesting. So this benchmark closely follows the guidelines around explicit set of priors designed to be as close as possible to innate human priors. Let me know what do you think, because there is a lot of debate going around this set. Some people think that this is unachievable and by humans. So but models are doing pretty good in it, by the way. Anyway, that's it. I hope that you enjoyed it. Let me know your thoughts. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network as it helps. Thank you.